Hi, welcome to part 2 of our tree diagrams lesson. We're going, in this one, look at a familiar problem, but we're going to look at it using the lens of tree diagrams to look at it a different way. Here's the problem. It's the Monty Hall problem. So we looked at last time, or recently, finally looked at the solution for that by writing out the full sample space of outcomes and then checking how many times a switch strategy would lead to a win. So let's look at it now in terms of tree diagrams. So as you may remember, you choose a door, then the host reveals a door, and then you have the choice of staying with your original choice or switching. So we're going to have one tree diagram for the switching choices and one tree diagram for the staying choices. And see if you can fill these in. So let's look at this tree diagram first. What are the three probabilities that go here? What's the probability of you choosing a car, a goat, or a goat number 2? And then what would be your probabilities here following that initial choice? Let's take a look how you fill that in. And just to see, check your understanding, let's follow this path. So what are the numbers here, here, and here? Oh, sorry. I should remind you here that these paths here represent, so a choice of a car the first time you choose a door, and then a win or lose based on switching. And again, win, lose, win, lose. So again, let's check your numbers for the top one here, all three here. Okay, well, this is how you could have gone about this. Your original choice, you have a 1 in 3 chance of choosing a car, 1 in 3 of goat 1, 1 in 3, right? There's an equal probability, 1 in 3, of choosing one of those when you select your first door. And of course, you don't know which one it is. And then if you chose a car and you're doing the switch strategy, so if you chose a car and you do a switch, well, you will lose because you were on the car and now you're switching to the other one and you don't have the car anymore. So you lose. So your chance of winning there is 0, but your chance of losing is 1. Okay, how about in this second one here? What would the two numbers be here then, considering what we did above? Okay, this time your chance of winning is 1 and your chance of losing is 0. The reason is if you choose a goat, then the host will reveal another door. He'll open the door with the other goat. And then if you choose the switch strategy, you will switch to the car. So you will have a 100% chance of winning if you chose a goat on that turn. And a 0 chance of losing because you will switch to the car. Now that exact same thing happens here on goat number 2, because if you choose goat 2, then the host will reveal goat 1, and then if you switch, you will switch to the car, and then you will have a 100% chance of winning. So win and lose is 0 here. So now when you look at this, and what would be the probability of winning a car using the switch strategy? So what would be the probability of winning under this strategy? Well, looking at it in terms of a tree diagram, we already know the answer from our recent work, but looking at it in terms of the tree diagram, the probability of winning can happen two ways here. It's the probability of choosing goat 1 and then switching to the win, or choosing goat 2 and then switching to the win. So there's only two paths that lead to the win, because this first path to the win here, when you multiply 1/3 times 0, it basically is 0. So we could include it here plus that chance of winning, but that chance of winning is 0 anyway. So our chance of winning under the first path is 1/3 times 1, and our chance of winning along this path is 1/3 times 1. So we have 1/3 and 1/3, which is 2/3. And we already knew that, but there it is under a tree diagram. It helps to really visualize that option. Now let's do the same thing over here. But this time we're going to try the stay with your choice option. So you make your original choices, and again, those are win-lose. Your original choices are the same. Again, 1/3, 1/3, 1/3. You're equally likely to make any selection. But now if you stay, what will happen to your two paths here? Well, the win chance will be 1, because if you chose a car in the beginning, the door with the car, and no matter what the host shows you, he's going to show you one of the two goats, you decide to still stay with your choice, you will have a 100% chance of winning because you already chose that car. And the lose will be 0 because you're staying, so you'll get the car. Now, what are they going to be here for the goat? If you chose goat 1, what's going to happen if you stay with your choice over here? Well, 0% chance you will win because you chose the goat and you're going to stay with that one. And then 100% chance you will lose. And it's the same down here, because if you chose goat 2 and you're unwilling to change, you will win 0% and 100% chance you will lose. So now what's the probability of winning using this stay strategy? Look at this and look at all the wins. Okay, so in this case, winning occurs along only one path, which is you chose the car, so chose car, and then you go on to win. Only that path leads to win, because again, yes, there are wins here, but those wins are impossible. They're 0, so 1/3 times 0 is 0. So you could add the two winning paths here that are the goat paths, but they both have a value of 0, so unnecessary. So the chance of winning here is only that one path, the one where you chose the car in the beginning, and now you will stay with the car. So there's only 1/3 chance that that happened. And altogether, those make 1. So that's a great lens through which to look at our Monty Hall problem, the problem that has followed us for the entire unit, and it's really nice to see all the pieces of probability coming together here in these tree diagrams and the logic we use here. Okay, so now let's look at some IB past exam problems to wrap up our unit on probability. Here's our first problem. Take a look, fill in the blanks here. Okay, now you're ready for part 2. Try to answer that problem. Okay, and now question B. See if you can solve that. And finally, question C. Okay, so maybe you got those all right, maybe you got some right, some wrong, and you want to check your work. I'm going to show the work on the next slide, but do know that this is a very typical kind of probability problem. Notice that it's 5 marks, 5 marks, and 4, which makes 14. So this would be like a long response problem, and this would probably be on paper 1 with no calculator used. So kind of a big problem, uses a lot of the ideas of probability in one problem, but if you really get the details of what we've looked at in the last few lessons, hopefully this went okay. Let's take a look at the answers. So here's all that. Check your work there. I won't go through explaining the details. I think you're at the point where you can sort this out, but let me move you on to the next problem. Okay, so here's the next one. It shows a tree diagram that's been created for you, and it asks these questions. So try question A. Okay, now try question B. And now try question C. So again, very typical kind of problem. Let's look at the answers now. Check your work. So here's all that. In many ways, the toughest and most important is part C, which gets into conditional probability. So take a close look at what was done there. And I think that's all I have for you with the tree diagrams. Now take some time and work on the practice assignment about tree diagrams. It will help you kind of solidify your understanding. And we will see you, well, yeah, this is the end of your summer lesson series. We will see you in the fall and where we wrap up probability together. See you soon.